Okay, guys, you'll never believe this, but I just recorded an entire lesson without turning on the microphone again. I need to leave a little note to myself to make sure that doesn't happen. So here we go. I'll do this lesson twice because I'm not a big fan of what I did the night before, leaving you silent for a little bit. I know it takes a lot of time. Let's look at Chapter 1, Section 7, three-dimensional figures. I have put three figures up here. They are the cube, the cone, and the pyramid. The difference between a two-dimensional shape and a three-dimensional shape is another variable. Two dimensionals are x and y axis, and three-dimensional dimensionals are x and y and z axis, which, for excuse the word, it gives the shapes their shape. A cube, you're looking at boxes, sugar cubes, packaging, anything, cones, ice cream cones, traffic cones that you see on the roadways, um, pyramids, the ancient pyramids of Egypt. That would be my best representation of those. So instead of finding perimeter and area of these things today we're going to focus on surface area and volume. Surface area would be if I took wrapping paper and wrapped over it, how much would I need? Volume would be if I filled it with a substance, how much would it take me? So I've already started working on a problem because I had it on the previous example. And so let's go ahead and take a cylinder. Before we do that, I'm sorry. Go ahead and flip to page 69 when you get into class tomorrow. At the top of page 69, under Key Concepts, it lists a table for surface area and volume of prisms, regular pyramids, cylinders, cones, and spheres. And so that will be very effective in the classwork that we do when we meet the next time. Again, prisms, regular pyramids, cylinders, cones, and spheres on page 69. So I'm going to go ahead and take a sphere, and I am going to, you know what I'm going to do? I'm going to use my shade technique here. And I'm going to use it like that. There's my sphere. The distance of 6 feet is a radius, and then the distance of 18 feet is my height. That's the distance measured from the two circles. And so we're going to find total surface area and volume. Okay, total surface area and volume. And so my first one is going to be total surface area. And that equation is 2 pi RH, that's 2 times pi times the radius times the height, plus 2 pi r squared, 2 times pi times the radius squared. You'll see that the next step, I just substituted in my values, 2 times 3.14 times 6 times 18, and then 2 times 3.14 and 6 squared, which eventually will end up being 36. I then take those numbers and multiply them together and come out with 678.24 and 226.08. I'm going to add those numbers together, giving me a grand total of 904.32. The book is going to ask you to round to the nearest tenth, so that's going to give me a total surface area of 904.3 square feet. Anytime I'm dealing with area, surface area, anything that uses the word area, I'm going to use square units. Okay, now let's look at volume. It is represented by pi r squared h. So again, like we did on the last one, let's just do, I don't want to lose all that. Let's do some substitution. We know pi is going to be represented as 3.14. Radius is 6, so I'm going to square that, times the height, which is 18. That gives me a grand total of 2,034.72. And then I'm going to round that to the nearest tenth. So 2,034.7. Now this is volume, so this is going to be feet cubed. Okay, so there is a surface area and volume of a cylinder. Again, you can find all of the formulas for all of the shapes at the top of page 69, and we will focus on those in class tomorrow. Chapter 1, Section 7, Three-Dimensional Figures.